Thanks everybody for coming, and thanks everybody who's online. Because of a tech issue, I can't see all of your faces or who's logged in, but I'll assume that you're there. So thanks for the introduction, James. So I'll just say a little bit about myself and what my role is. So I'm a research software engineer at the University of Bristol, and the kind of task that we have in universities is to boost the literacy and the way that we use computers in order to create more robust and reliable and reproducible code in research. We do lots of teaching as well. So we teach Python and C++. We teach software engineering practices and how to use version control. You might have heard of Git or GitHub. We'll be talking a little bit more about that later in the session. If you haven't heard of these things, don't worry, I should be talking about them. So currently I am, as a research software engineer, I work on a technical project in environmental mineralogy. The goal we have with this at the moment is to build an open platform for analysis of samples. So this is for people who are working with environmental samples. So they might be going to some kind of rock outcrop, or perhaps they're going to some moorland. The group that I'm with are particularly interested in the biochemistry and the biogeology of peat moorlands. And often we need to take samples and we need to look at the spectrums that are made from different methodologies. These might be X-ray diffraction and Raman spectroscopy. The point is that we needed a way to build a platform that can be used on the web, that could be interacted by anybody in the field, and who can then use that for looking through reference databases and also being able to upload their own data or to collaborate with others. And Streamlit is a solution that we went with, and we're still in quite early days of its development. We might have a look at it a bit later. But really the goal of the session of this talk today is to give you an overview of what Streamlit is. We'll talk about how it can be used in research and in education. And I will try to do a practical demonstration, which we'll see how that goes when we get there. I should also give a thanks, especially to James, who gave the introduction. He has been extremely helpful in getting this together. I also want to say that this is really a jumping off point for some training we'll be doing next year. We don't know quite when, but hopefully in the first half of next year, when we'll be, since we already do training in Python, we're going to be adding a new unit where we'll be teaching the Python you require to use Streamlit. So this is very much a kind of prototype session, which will eventually build into a full afternoon workshop or morning workshop, one of our 3-hour workshops. Yeah, if you keep an eye on our emails, if you're interested about that, you'll see something next year. Okay, so I've already mentioned what's on the slide. We'll just be talking about what data apps are, the advantages and the disadvantages of them, and then finally we'll have a look at a bit of okay, so we'll start by talking about what a data app is. I guess it's a fairly woolly term, but it's what Streamlit themselves describe themselves as doing, is making a data app. Data app uses data, and it is an application which is shared through a browser. So it's a way of exploring data, analyzing data, and also producing visualizations from that data, but in a way that is open and shared to the world. So the advantages of doing this, of course, browsers are completely portable. As we say in computing, is can be used in any operating system. You don't have to worry about what you're running. You can just open up a browser and you'll be able to see and use a data app. I think that we've all seen really what data apps are. Certainly in the past 10 to 15 years, we see more and more visualizations. Say on news sites, you might have interactive maps, or you might have graphs that you can look at. I know that during COVID, we had all of those visualizations that you could interact with. Now, while those are data apps, the way of making them requires some technical skills that we don't typically see in academia or education. So when it comes to coding in research, we tend to use languages which are used for analysis. For example, Python, R, C++, perhaps Fortran. And these languages are not designed for, they're not web development languages. And when you see a really swish-looking map and really slick-looking visualizations, those are generally made using JavaScript. And JavaScript is extremely good for doing that kind of work, but it isn't useful for analysis or building algorithms. It's not a language which has really any take-up in academia. And therefore, we have this gap where we have people who can write, say, Python and understand the flow of C++, but these languages are not particularly useful for web development until now. And so Streamlit is a way of uniting the language, which is Python, and a way of building things for visualization for a browser. I'll just show a couple of screenshots of examples here. There are links, but I won't go through to them at the moment. But here is a couple of examples of academic styled data apps. This one is to do with airflow and designing the profile of aerodynamics, not an area that I really know anything about, but it's a way that you can change parameters and you can see what's happening, and there is some kind of processing happening, and you can then extract data from that and download things. Here's a data app that my colleague Nina Dakara was the main. She did almost all of the work on this. I did some of the graphics to help with that. This is a data app that we made during COVID, which was actually requested by Public Health Wales, and it's a mapping app which allows you to look at particular aspects of the areas to see whether a particular area might need extra support during COVID. So we'll be looking at the amount of community support, and it also took in the sentiments from Twitter so that we could see if there was any major kind of hotspots of people saying, oh, I've got COVID and so on. And again, that was a huge amount of work, and it would have been really nice if Streamlit kind of existed. It did exist at the time, but it was still quite new. So the amount of hours that went into building that website, I guess it was, how many people on the author list? I guess about 10, and it took us 3 months. So you can kind of see it as 30 months of work really to put together that data app. I've put this one up as a kind of demonstration of a very sophisticated data app. I won't open it, but you can probably get a sense of what it does. This is for the Economist magazine. The Big Mac Index is a kind of a very rough estimate of looking into the economies of different countries and different currencies. And this is very sophisticated. You can select different countries and you can select the information here, and it keeps on modifying it in a very nice animated way. The reason I add this is because it's a demonstration of a really kind of high-end JavaScript style data app, which very soon Streamlit will be able to do. So that is really exciting to know that we'll be able to do this kind of work without needing to be a professional web developer and use JavaScript. So I guess I've already mentioned a few of these points, but there's a huge potential for using data apps. It's especially given, I mean, I'm a software engineer, and in research, we are always trying to make sure that people write reproducible code, robust code that they can share. And when people say publish a paper, they share their code and others can review it. And I think that data apps link into that nicely, so that instead of, while you might have a figure, a static figure that you put into your papers for publishing, you can also have links to a data app so that people can explore your data for themselves. They can make their own figures. It's very easy to make your own figures, and generally it really fits well with the open research philosophy. So yeah, I think that I think in the coming months and years, I think that this will become more and more a part of research and how we publish things, and encourage others to collaborate as well. So what we really don't want to do when we're taking up with our time writing code for analysis and writing algorithms to investigate our data and try and pick out the meaning, to actually build a story and see what your data is saying. But like I said earlier, we would never do that with one of the web programming languages, so HTML, CSS, and JavaScript. And I think that even more so than languages like Python or C++, these languages are always in very, very rapid development, and keeping up with modern JavaScript is something that really you need to be a professional in that area. And in academia and in research and education, very few of us would really have the time to become experts in JavaScript, which you would need to do in order to produce the kind of data apps that we want to make. So the solution to this problem of needing to know difficult web-based languages is through different types of software and languages and libraries. When I say a library, that means a package that you include with a language that you're writing in order to boost its functionality. So there are different ranges of there's kind of a spectrum of very graphical user interface style applications. For example, we've got Tableau and Power BI. Power BI is made by Microsoft, I think. And these are used for making visualizations. Power BI is definitely something you have to pay a lot of money for. The BI stands for Business Insights. Tableau as well is proprietary, so you need to pay for it. Admittedly, you can get it free for students, and we do sometimes do talks on it. It can be very useful, especially for mapping. And the other things I've mentioned here, so Shiny is part of R. So R Shiny is a way of making data apps in R. Dash is interestingly, these are all essentially wrappers around JavaScript. So we've got Dash, which is Python packaging, which is then actually running JavaScript in the background. D3 is basically JavaScript, and it is the kind of the underlying workings of all the JavaScripty good-looking slick visualizations you see on the internet. And Bokeh is also another graphics library that we will look at in a moment. But all of these really have issues. Certainly things like proprietary software, getting a license for it is expensive, and you don't have a great deal of, you don't write code, you're interacting with a user interface. R Shiny is quite well used, but it's getting quite old now, and it's not quite as nice when we know that the internet has got some really cool features in modern browsers using very modern HTML. Our Shiny doesn't really take advantage of those. D3 is very difficult to write. It's a complex language, and Dash itself also has some proponents, but it can be used by Streamlit, and so we will talk about that now. I thought I would just put this up as a demonstration of how quickly Streamlit is becoming the kind of Python maybe standard for making data apps. I think James has pointed out that stars are not always the best way of judging the quality or the usability of a language, but I still think it's an interesting graph to see the development of Streamlit and how quickly it's taken off. So it was only released at the start of 2020, and today it has kind of more interest than both Dash and R Shiny. So this is actually a graph of GitHub stars. So stars is when people will add a kind of like, if you like, on GitHub. But it's becoming a useful way to track at least how much interest there is in different repositories, which is on GitHub. So Streamlit itself addresses a lot of the issues we're having in that it's pure Python. It has a high-level API. An API is an application programming interface, which is one of those acronyms which I don't find very helpful because it's always going to be an application, it's always programming, and it should just be interface, if you ask me. It has an interface, which means that the way, the lines of code that you write, the kind of way that you ask functions to be run. It's very quick to use, and I'll hopefully demonstrate that. It's got a really nice way of, when you're working with it, you can see the changes in the browser in real time. In the past, I've worked with things, and if it's for the browser, you're often refreshing, and then you have to get rid of the cache, and then you have to reload again. And it's a real stop-start way of developing. And also, Streamlit is very much streamlined for getting things up on the internet really easily. So you have options for deploying, which are very easy to use. And if all goes well, I shall also try to demonstrate that. One of the other major benefits of Streamlit is that it can use all of the other major Python graphics libraries. So the two kind of old school but still very powerful graphing packages in Python are ggplot and matplotlib. And those can be imported into Python and used to create your visuals. But Streamlit itself has a very easy way of accessing Plotly and Bokeh and Altair, all of which make really very sophisticated products. And it's really nice to have the option to mix and match these different packages. Some of them have particular strengths. Some of them are very powerful for interactions, so you can actually select data in the browser and have your visuals updated. So, yes, as I've already said, the benefits of having this really straightforward interface is really, really helpful, and it allows you to write code that's easy to understand, easy to share with colleagues or collaborate on, and people can see what you're doing, and it's not really dense kind of JavaScript-y style language. The compromises, the downsides, I don't know if it's a downside or not, but you do need to have at least a basic understanding of Python. Everything is written in Python, correct? The performance of the actual data app itself, it won't be as good as if it was written in JavaScript, because Streamlit itself is essentially just calling JavaScript behind the scenes. It will never be as performant as straight JavaScript. But that is getting better. I think one of the things I'll show in a moment is that Streamlit is in such rapid development, and it keeps on, even on a weekly basis, they seem to add new features and fixing bugs. And one of the major complaints or observations is that it can be a bit slow, but it's getting better all the time, which is good. And compared to if you're writing, say, HTML, where you can say where you want things on the screen are to the pixel, it's not quite as precise as using that kind of code. So these are just I picked out some of the issues that people have complained about. And all of these have now been dealt with, which is great. So initially, there's only a single static page that you could use. That has now been updated, and you can have tabs and as many different parts of your page, which we would all expect from a modern website these days. We now have a native authorization, which can also link with OAuth 2. So you would be able to log in using one of the modern ways that you can say log in using particular, say log in with Google, log in with one of the other major platforms. Page caching is links into what I said in the previous slide, which is to do with performance. That is now implemented. Also, given it's a data app, people wanted the ability to be able to work with databases, and it now has SQL, or at least SQLite, built into it as native, which is great. And tabs I've already mentioned, and it's getting more precise every day. So again, I'm just trying to mention how dynamic the community and the developers are for building this. Okay. Okay, so at this point, I am going to just show you a couple of examples of some working Streamlit data apps. And oopsie, and then I'll do a practical demo, which is always a bit dangerous. So we'll see how we go with that. But first off, we need to just bear with me whilst I open a browser, which for some reason I can't do. Does it put it onto another screen? Oh, I think I need to stop doing that. There we go. I don't need to see all of my options of wish me luck. Okay, so I'm just going to show you a couple of examples. We're on Streamlit's website now. Let's just go to their gallery here. So they have several categories of kind of pre-made data apps. Some of them are made by themselves. You'll see it says by Streamlit. There was one in particular which I really liked the other day. I should also say that the people making Streamlit have designed it to be very focused towards machine learning and for applying models which have been made. So there's a real kind of lean towards those kind of apps, but any kind of app can really be made. Oh yeah, this is the one I really like. Hopefully the internet will behave. So here's just a quick example of an app that the group has made. Their research field is in the RAS protein and looking at, I presume, active sites on those molecules. And they've integrated this visual here, which if I go to, where was it? No. I can't remember what the link was, but it doesn't matter all that much, because the main point of this is that if I could find the right link to find things, we have the ability to look at different molecules and in particular to view these kind of active sites. But the point is that they managed to integrate a really quite sophisticated visualization by just bringing that into Streamlit. There's another example that I wanted to look at. So this is a built by some physicists and looking at gravitational waves. So since the first gravitational wave observations about 6 or 7 years ago, there are many more of these observations made, and they've been cataloging them and allowing you to look at these in different ways and then analyze and modify what you're doing. I seem to remember that this one takes, I don't actually know what I'm doing here, but it's a way of changing the way that you view this data, which to an astrophysicist would make some kind of sense. But note that, oh, actually, I'll show you what I mean with something else in a moment. Okay, so if you are interested, there are many more on their websites to look at. But right now, oopsie. So I'm going to do a demonstration of just how little code you need to write to build an app. So we'll see how we get on with this. On the left-hand side here, I just have a, it's basically just a text file. Well, I'll be writing some code. And on the right, I've got a browser window, and we'll be able to see what we're building as we go. Also, has anybody here heard of GitHub Copilot? Yeah. So GitHub Copilot is the notorious AI which will write the code for you, which I recently, they gave me a free access to, because I think it's because I'm on their educational kind of list of people. So we'll see whether GitHub Copilot is any good at writing code. And to be honest, it's kind of scaring me how good it is at writing code. Okay, so let's start by, how many people in here know what Python looks like? Okay, good. Most people, good. Okay, so I'm just going to start by doing an import, Streamlit as st. So st is just the standard abbreviation for Streamlit, a bit like how you'd say import pandas is. Make it bigger. Let me try. Is that any better? Less. There. Is that okay? And so the grey bit is the AI just suggesting what I should do, and it's absolutely right. We do need pandas as PD, and yes, I do need Altair as out. So pandas, if you are unfamiliar with it, is a data science library for Python. but for some of us, it kind of is what Python is. It is a super powerful way of organizing and analyzing your data. So we'll need to use that. And Altair is a graphics library, which we'll use for making a visual. So we've got our imports. It's suggesting that I write an image. I don't want to do that. I want to go sd.write. And yeah, I kind of do want to say that. Let's say something else. Okay, so I've saved this file. Now, I'm just going to locally host it. So basically that means just make a website, which my computer is just showing to my own computer. But in a moment, we'll show deployment as well. But if here we go, so don't worry about it. You don't need to look at this again, but I just was running Streamlit so that it is local and we already have a website. That's handy. Good way of starting. Now, I'm just going to demonstrate a few ways to make this a bit nicer and more interesting. Let's add a header. Yes, I did do that. So here I'm just asking for the header function to be called. And as soon as I save that, you'll see it's added in a header. What? Which one? And let's add in something else. I want to add in an info. Yes, it already knows exactly what I'm going to do. So you can see that just by writing 3 lines, we've got a useful basis of a website starting to be built. Doing this in one of the web languages would take a lot more code. But I'm going to add one more thing. Let's go sd.sidebar. I don't want an image. I just want to go sidebar and say this is this. There we go. So it was asking me then what do you actually want to do in the sidebar, and I wanted to do some writing. So I've added just a bit of text there, and we have a very nice looking sidebar. So it's built that for us. And we can add an image to that. So let's add in here st.sidebar image generic logo. Yes, it does know. And that's quite creepy because GitHub Copilot must have looked in the folder to know that was there. Interesting. And now we've got a logo. So we're already building a website. At this point, I'm going to quickly show you what is in their actual API to show you what's possible. So I'm just going to quickly open another website. So Streamlit themselves have their reference, their manual, which is it's really well written. They need to add new things because they keep on adding things so quickly that they haven't added to it. But most usefully, we can see that we have different ways of interacting with data. So here we have different types of buttons, and they can all be used to do kind of callbacks so that what a button is doing can then be used elsewhere in your scripts. Let's add one of these to our. So on the sidebar, well, actually, let's do it in the main body. Let's do dot. Let's do a button. Let's see. What does? Oh, Copilot doesn't want to fill it in for me. There. So we already have an interactable item here. And now I've completely forgotten what data I was going to bring in, but I will give it a go. I think I wanted to go equals data frame. I'm going to have to look at my original to remind me what I'm doing. Oh yeah, that's what I was going to do. Okay, that's a good idea. That's good. So on this particular line here, we can then assign the output. So we've created what we call radio buttons. Radio buttons are essentially mutually exclusive buttons. You press one, the other ones can't be pressed. I presume called radio buttons because of old school radios. Not quite sure. In any case, I can assign what that button is to a variable, and I can also include. Oh, I've already done it. I can also include a data uploader. So here with one line of code, well, 3 lines of code, we've created a data uploader. Let's bring some data in. I'm afraid it's not the most fascinating data of all time. It is data about dollar inflation over the last 200 years. It was the cleanest data set I could find at quick notice. Okay, so we've built that and we've uploaded that data. And now we're just going to plot that. And I will admit that the code I'm about to put in is a little bit longer, but so this is just to allow us to plot. And I think this is the nice thing about Streamlit is that when you don't have to worry about building and layout and what everything looks like, you can concentrate on your visuals. I'm using Altair as my graphing library, which does require some extra syntax, which is slightly in depth. But it's nice being able to just focus on that as you're coding. Okay. So now I've brought that in, and we already have a website with some data and an interactive graph. So, so you could easily be looking at this, and you might have particular interest in a particular area. And you also already have a way of creating images, both as PNGs. Is SVG a vector format? So you can make vector images. So you could very quickly be building the good quality graphing that you might want to use in a publication or some other area. So that's already there. Good. So we've already gone in just a few minutes, going from having nothing to having a decent looking website with interactivity and with an ability to upload. You could easily also have login sections, you can have databases, and you can have all kinds of graphs. In fact, it's worth very quickly just showing Altair Gallery tends to bring up pictures of some bloke in a hood. That's interesting. Is Altair some character from? I don't know. Anyway, this is what we really want. So earlier I mentioned we have Altair and Bokeh and Dash, all of which allow you to, with a pretty short line of code, allows you to access these visuals, which can be highly sophisticated and very beautiful, and you don't need to worry about all of the difficult JavaScript that's behind it. You just call them and there they are. So these are just the ones which Altair can do. But of course, you've got any of the other graphing libraries which you can use. Now, finally, in the last couple of minutes, what I wanted to do was demonstrate. So here we've got the website that we just made using Streamlit, but this is just local. So it's only on my machine and only my machine can see it. But what if we wanted the world to see it? Well, we can go. Here we are. So what I've done here is I've logged into Streamlit and I've gone to my own applications page. So literally this is a matter of minutes to log into Streamlit, make an account, confirm your email address, and then you get to your own area to build your own apps. And it's defaulted to, you link it to a repo. So in my case, we have all of this, and I can send this to GitHub. So let's go. So I'm just doing a commit. I'm sending that to GitHub. And that's all done. So I've sent that to a repo. Now I can go new app from existing repo. And because I've allowed GitHub to Streamlit to access GitHub, it knows what my repos are. So I can go. So I've saved it on GitHub as this name. And we can go, whoopsie. That's not right, that is right, demonstration.py. So all I've done is I've gone to the repository on GitHub and I'm telling it that this is a Streamlit file. And then it takes a moment or two, but literally it's just a few clicks and you have a website which anyone can go and view, anyone can use, and compared to the difficulties that we go through normally through trying to get a domain and getting servers and anyway, all of the things that you need to generally deploy a website is done for you in hopefully mere seconds. Oh, it's default. Oh, it's because my machine switches to dark mode when the sun goes down. So I just changed this to light mode. Whoopsie. Settings, use light mode, just so that it's consistent with what we had before. So there we go. We have our own website and it is open to the world. So anyone in the world can go and have a look at that right now. And if they wanted, they could go, I want to analyze something really, I'm really interested in the dollar inflation. I can do that. And they can start analyzing it for themselves and looking at this, whatever analysis they want to look at. So I've managed to go on for nearly an hour, but just to recap what we've covered today is the reasons why data apps are useful. And I think it's a very new and it's a very powerful way of getting across the message of your research, and it's very useful in teaching and in particular how to use Python. And I did a quick demonstration of writing it, and I hope you could see that it's only a few lines of code to build a fairly decent, I mean, this is just the basics really, but a fairly decent looking website. And then I demonstrated that it's really easy to deploy. So So with that, I think I'll bring things to a close, but you are very welcome to ask any questions if you like.